Hey guys, what's up? It's Travis, and here's the third 9 weeks review. It pretty much covers rotary motion, law of sines, law of cosines, double angles, half angles, and composite argument properties, which is your angle sum properties. And I think that's all we need. So let's get into it. Let's talk about what questions we can use a calculator and what questions we don't need a calculator for. All right, so here we go. Two boats start at the same point and speed away along courses that form a 110-degree angle. If one boat travels 24 miles per hour and the other boat travels 32 miles per hour, how far apart are the boats after 30 minutes? All right, so they want to know how far apart these boats are. So I'm gonna draw a triangle, not to scale. So they both start off right there, and then one boat travels for 30 minutes. So if you travel 30 minutes at 24 miles per hour, that's going to give you a distance of 12 miles. So there it is, 12 miles. And then the other boat travels for 30 minutes at 32 miles per hour. So that's going to give you a distance of 16 miles. And there's a 110-degree difference between them. So there it is, 110 degree. And they want to know this distance here. They want to know that distance. I'm going to call that x. So it's obvious on this one that it's the law of cosines. So here we go. Law of cosines. I'm going to write x equals the square root of 12 squared plus 16 squared minus 2 times 12 times 16 cosine of 110 degrees. Yeah, that's all you do, guys. You type that into your calculator and you get 23.057 miles. So there it is. All right, here we go. YWA is having a pumpkin sale for Halloween. The pumpkins will be displayed on a triangular region in the parking lot with sides 45, 65, and 100 feet. Each pumpkin takes about 3 square feet of space. So I have it says how many pumpkins can we display? So we have a triangle, not to scale. So here's my triangle, guys. I'm going to call this A, B, C. And I'm going to say this is, I'm going to say that this is 45. I'm going to say that this is 65. I'm going to say that this is 100. So there it is. And they want to know how many pumpkins I can fit in there. So I need to find this area. So either you find an angle, and then you can use your area of a triangle, 1/2 AB sine C, or you can use Hero's formula. Hero's formula is this, guys. It's the square root of S times S minus A times S minus B times S minus C, where S is called a semi-perimeter, which just means half of the perimeter. So half of 45 plus 65 plus 100. So let's see what that is. Where's my calculator? All right, so 100 plus 65 plus 45, that's 642, 210, and then half of 210 is 105. So that's my S, and then I'm literally just going to go, my area is the square root 105 times, and then 105 minus A, so this is A right there, 105 minus 65, and then 105 minus B, then the B is, in this case, 100, and then 105 minus a C, and the C in this case is 45, and the square root's on bottom of all that. And I get the area is if I didn't make any mistakes, I got 300 square root of 14, which is the same thing as saying 1,122.5. Let me just make sure. Okay, I'm going to put more digits, guys. 0.4972. 4972. All right. So there it is. We haven't even answered the question yet. This is the area. Each pumpkin takes up 3 square feet. If each pumpkin takes up 3 square feet, and this is my area in square feet, then to find the number of pumpkins, I'm going to put number of pumpkins. So PUMP stands for pumpkins, not pump. So to find the number of pumpkins, I take this area, 1122.4 4972, and I divide by 3 because each pumpkin takes up 3 square feet. So I get, oh, hold on. Come on, buddy. I'll just do it right here. 1122.4972 divided by 3. And you get 374.166 pumpkins. We can't have 0.166 of anything, so it's just 374. Now recognize if it would have said 374.8, you would still round down to 374 because you can't have 0.8 of a pumpkin. You have to round down. Pumpkin. I can't even spell. Pumpkins. There we go. Hopefully you guys enjoyed that one. My apologies if I confused you. All right, it says find the measure of the smallest angle. So recognize that the smallest angle comes from the smallest length. I see that 45, so my smallest angle obviously has to be angle C. So here we go, guys. I'm going to write 40. I'm just using law of cosines. I'm looking for angle C here. So I put the 45 squared on the outside equals 100 squared plus 65 squared minus 2 times 100 times 65 cosine of C. All right, 45 squared is, I probably should know that off the top of my head, but 2025 equals 100 squared is 10,000. So let's just go ahead and add up these guys already. So I think that is 14. Okay, so 14225, 14,225 minus 2 times 100 is 200 times 65, and you get 13,000. 13,000 cosine C. So the first thing you do is you're going to subtract the 14,225, guys. So minus 14225 minus 14225. So you're going to get negative 12,200, because that's just 2025, equals a negative 13,000 cosine C. So now we're just going to do negative divided by negative, which is a positive. So cosine C is equal to 12,200, and I know it reduces, but I'm not going to bother, over 13,000 there. And then to get C by itself, I'm going to put an arrow. C, the angle C, is going to be arc cosine of that, 12,200 divided by 13,000. 0, that should, 0, 0, 0. And you get 20.2052 degrees. I'm fine if, for degrees, I'm fine if you just say 20.2. But there it is, guys. All right, we're done. That's it. That's all your review. No, I'm kidding. I don't know. That probably wasn't funny. I apologize, guys. All right, next question. The short side of a triangle with angle 50, 60, and 70 has length 9. All right, so I'm just going to draw some random triangles, not to scale. None of my triangles are to scale. So 50 degrees, 60 degrees, and 70 degrees. And the smallest has length 9. So that means the 50 degrees creates the smallest length. So I'm going to say 9 there. And what do they want? What is the length of the longest side? So the longest side is created by the 70 degree one. So I'm going to put X there. And here we go, guys. So I'm going to write, this is a clear indication of law of sines. So I'm going to write sine 70 degrees over X is equal to sine 50 degrees over, let's see, sine 50 over 9. I'm going to cross multiply. So let's see, X sine 50 degrees equals 9 sine 70 degrees. And I'm just going to divide by sine 50 to get X by itself. X equals 9 sine 70 degrees over sine 50 degrees. So I do that, guys. I type that into my little calculator, and you get 11.0401, and there it is. Okay. This one here, I think you can do without a calculator, guys. It's taken directly from a UH assignment. It says the string running from the ground to the top of a fence has an angle of elevation of 45 degrees. The string is 6 feet long. What is the distance between the fence and where the string is pegged to the ground? All right, so here's the ground. Here's where the little peg is at, and here's my fence. Looking at it from one of the sides there, and there's my string right there. So they want to know how far away you are from the fence. So this angle was 45 degrees, and I know that this is 6 feet. So because that's 45 degrees, I have a 45, 45, 90. And you can say either 45, 45, 90. There's two ways to do it, and square root of 2. So you can say that the 6 is for the n squared of 2. So you want to get n by itself. So n squared of 2 equals 6 divided by square root of 2 divided by square root of 2. And you get n equals 6 divided by square root of 2. You got to rationalize it because 6 squared root of 2 is not in there. So you get 6 square root of 2 over 2, which is just 3 square root of 2. So there's one way. Another way to do it, you can say with respect to the 45 degrees, this x is adjacent, that 6 is hypotenuse. So you can say cosine 45 degrees is equal to adjacent divided by hypotenuse. And then you just multiply by 6 both sides. So 6 cosine 45 degrees is equal to x. And then you just remember that cosine 45 is just square root of 2 over 2. And then 2 goes into 6 3 times, so 3 square root of 2. Both routes are just as good. Do whatever route you feel pleases you. All right. This one here is an example of one that you can do without a calculator. So I might ask you to not use a calculator for this one, guys. It says draw a triangle ABC with sides BC as the base. The measure of angle A. I know BC is the base, but I think I'm going to draw it a little different here. The measure of angle A is 30 degrees. If the perpendicular drawn from B to side AC, the height is 2 centimeters. What is the length of AB? I'm going to draw it a little different. Here's what I'm going to do. I'm going to draw it like this. I'm going to call this A, B, C. And I did that for a reason. A perpendicular is drawn to side AC. So, perpendicular. And now it makes this problem way easier. A is 30 degrees. I want to figure out this height. And they give me the height. The height, oh, that's not a height. That's a hypotenuse, sorry. The height of this triangle is 2. So that's 2 centimeters right there. So there it is. It's really simple now. So this is the 30, 60, 90 triangle. And there's many ways to do this, guys. You do not have to go this route. I'm just trying to do the easiest route. So that height is my short leg. So my short leg is 2. So then that means my hypotenuse has to be 4. So there it is. I don't see any mistakes. I don't think I made any mistakes. I think we are good. Let me read it just in case. If an angle, the measure of angle A is 30, perpendicular drawn from B to side AC. Yeah, that's correct, guys. We're good. All right, let's keep going. All right, so this one here, we can do this one without a calculator. So put no calculator. No calculator. All right, give it an honest attempt. Try it out. It says given triangle ABC, the measure of angle A is 60 degrees. So let's draw a triangle. A, B, C. Angle A is 60 degrees. And then, let's see, the length of AB is 6, so I'll put a 6 there. The length of AC is square root of 2, so square root of 2 down there. What is the length of side BC? Okay, this is obvious that it's going to be law of cosines, guys. So x equals the square root. I have the 60 degrees, so that x goes on the outside. 6 squared plus square root of 2 squared minus 2 times 6 times square root of 2 cosine 60 degrees. And everything can be done without a calculator. 6 squared is 36. Square root of 2 squared is 2. 36 plus 2 is 38. So maybe that's already giving you little hints of what the answer might be. So 38. Let's see. 2 times 6 is 12. So I'm going to write 12. So minus 12 times square root of 2 times cosine of 60 is a half. So half of 12 is 6, guys. So now I have 38 minus 6, and I still have that square root of 2 there. And you probably could have reduced it, maybe, or maybe you could have factored out something, but I already see the answer. I don't see any errors, so there it is. All right, so here's another one, guys. No calculator. ABC is triangle AB with, so let me draw a triangle ABC. ABC. They say that AB is 9, so AB is 9. BC is 14, BC is 14, and AC is 12. And not to scale, of course, as always. Find cosine A. All right, so if I want cosine of A, I have to use law of cosines because that's what has cosine in it. So if I use cosine A, if I'm trying to find cosine A, I have to use a 14 on the outside. 14 squared equals 9 squared plus 12 squared minus 2 times 9 times 12 cosine of A. All right, so now 14 squared is 196 equals 9 squared plus 12 squared, that's 225, minus 2 times 9 is 18. 18 times 12 is 216. Cosine A. Subtract 225 from 196. What's that? Negative 29 or something? 25, 216, 229. Yeah. Negative 29 equals negative 216 cosine A. And then negative divided by negative is a positive. So I'm going to write cosine A is equal to 29 over 216. So there it is, guys. Yay. See, we're on our way. Oh, that little noise that you heard, I did not fart. That was the chair, guys. Scout's honor. All right. Let's go to the next one. So the next one here, it says determine the angle X in the triangle given below with AB is 8 and BC is 11. So AB is 8, BC is 11. And it says to use the law of sines and a double angle. So remember that a double angle formula, so let me write it here. Sine of 2A is equal to 2 sine A cosine A. So we're going to use that. We're going to use that in a little bit. So here we go. Sine X over 8 is equal to sine 2X over 11. When I cross multiply, I get 11 sine X equals 8 sine 2X. So now I'm going to replace the sine 2X, guys. So 11 sine X is equal to 8 times 2 sine X cosine X. So 8 times 2 is 16, so I'm going to write 11 sine x equals 16 sine x cosine x. If you divide both sides by sine x's, the sine x's will cancel out. So now I have 11 equals 16 cosine x, so I'm going to divide by 16 to get cosine x by itself. So cosine x is equal to 11 over 16. And then to get x by itself, you got to take the inverse of it. So arc cosine of 11 over 16. If I went too fast, guys, please rewind it and look at it again. Oh, what happened there? All right, here we go. So this is another one. Look, we didn't even use a calculator on this one, so there's another no calculator. And this one here, you don't need a calculator. No calculator required. Triangle ABC, angle A is 52 degrees. Angle C is 62 degrees, and BC has length 8. So let's draw that triangle. So A, B, C. Angle A is 52 degrees. Angle C is 62 degrees. And AB is X. That's what they want. And the length is 8 for BC. Okay, law of sines. Sine 52 degrees over 8 equals sine 62 degrees over X. Cross multiply. X equals 8 sine 62 degrees over sine 52. And that's it. All right, we're doing pretty good on time, guys. Let's keep going. So number 10 says, an isosceles triangle has a vertex angle measuring 150 degrees. The two equal sides have length Q. So let's see if I can draw that. 150 degrees, so there it is. I'm going to say that's 150 degrees. And this is Q and Q. The two equal sides have length Q. What is the length of the base in inches? All right, this is going to be the base, so I'm going to say that's X. And that's what I want. This is 15 degrees. It doesn't matter. We're not going to use the 15 degrees. All right, so just law of cosines. So x equals the square root q squared plus q squared minus 2 times q cosine of 150 degrees. And there's another one with no calculator, guys. So you can see a theme here. So now I'm going to have, let's see, 2q squared minus 2q squared times cosine of 150 degrees is a negative square root of 3 over 2 from the unit circle. So now, and I'm going to write it over here, x is going to equal 2, and I see 2q squared, and I'm going to factor out that q squared in a little bit. Negative times the negative is a positive, so plus the 2's cancel out, and you'll have q squared with a square root of 3. So finally, I'm going to put the equal sign, square root. Okay, so finally, if you factor out a q squared here, I'm going to have square root of q squared parenthesis 2 plus square root of 3. And the square root of q squared is just q. So q square root of 2 plus square root of 3. So that is looks like letter E. All right, use the appropriate angle sum formula, composite to simplify the following. So notice 9x, 9x, 3x, 3x. So that's an A, that's a B, that's an A, that's a B. So this looks like cosine A, cosine B minus sine A, sine B. And hopefully you remember that that is equivalent to cosine of A plus B. Yay. So you take 9x as your A, 3x as your B. So you just write cosine of 9x plus 3x. And that is 12. So cosine 12x. Let's keep going, guys. All right. So these can be kind of fun. They can also be a little cumbersome. But I'll try to get you guys through this as painless as possible, hopefully. So I have an angle X. So here's angle X in quadrant 1, because it tells me there. So angle X. And it tells me that cosine is 1, so 1. And then the hypotenuse is 9, so 9. 9 squared is 81, and 1 squared is 1. 81 minus 1 is 80, so this is the square root of 80. The square root of 80 breaks down to 16 times 5. So the square root of 16 is 4. So 4 square root of 5. Okay. Now from there, we should be able to tell, well, cosine here was given. That is 1/9. And sine of x is going to be 4 square root of 5 over 9. All right. So we won't hurt your eyes. I'll use blue. And this angle y is in quadrant 4. So here's quadrant 4. Angle y. And it tells me that cosine is 1 and that the hypotenuse is 11. So 11 squared is 121, 1 squared is 1, and 121 minus 1 is the square root of 120. Remember, this is negative because I'm in quadrant 4, and the y value is negative there. And the square root of 120, well, 4 times 3 is 12, so that means the square root of 4 is 2, so negative 2 square root of 30. So there it is. From that, we will get, well, cosine y was already given. Cosine y was a 1 over 11. But sine y is going to be a negative 2 square root of 30 over 11. We're ready now, guys. So here we go. I'm going to use black, a neutral color. The color of my soul. I'm kidding. My color of my soul is not black, guys. All right, here we go. Cosine x plus y. I'm going to write what cosine x plus y is up here. Cosine x plus y is cosine x cosine y minus sine x sine y. So that's all we're going to do. We're just going to plug in. So cosine x was given as 1/9, so I put 1/9. Cosine y was given as 1/11, so I put 1/11. Minus, and then sine x was given as 4 square root of 5, so 4 square root of 5 over 9. And then it says sine y, so sine y is a negative 2 square root of 30 over 11. So when you do that, let's see, 1 over 99 minus times the negative is a positive, and you get 8 square root of 150 over 99. And then that 150 breaks down, guys. Let's see. 150 breaks down 25 times 6, because if you have 6 quarters, that's $1.50. Yay for math. Yeah, for money, quarters. All right, and then 25 is a perfect square root. The square root of 25 is 5, and 8 times 5 is 40. So, and the denominators are the same, so I can add them up. So 1 plus 40 square root of 6 over 99. Notice that we didn't really touch a calculator. We could do this without a calculator, I think. So there it is, guys. What answer is that? See? All right, let's go back to red because I like using the color red here. All right, so I want a double angle and a half angle. So maybe the easiest thing to do is get your double angle out of the way. So cosine 2a, hopefully you remember, they give you sine. And don't worry, these formulas will be given to you guys, but I would hope that you're starting to remember these. That's 1 minus 2 sine squared a. And they already give you what sine a is. So I'm just going to go 1 minus 2 and then 3/5 squared. And I think we can do this without a calculator, guys. Let's see, 1 minus 2. And then when I square that, that's 9 over 25. And then when I multiply 2 times 9, that's 18, right? So 1 minus 18 over 25. And then just turn that 1 into 25 over 25. So that's still 1 minus 18 over 25. And the difference between 25 and 18 is 7. So there it is. So 7 over 25. So cosine 2a is 7 over 25. So maybe, no, because there's a negative there. Out, no, negative, and maybe. So 3 maybes. And I guess, look, I'm looking at a negative, positive, positive. So more than likely, I guess if you're a good test taker, you're probably going to choose a positive one because there's more positives than negatives. But before I even figure that out, I'm going to do this. I'm going to say half a. So a is between 90 and 180. So half a has to be between half of 90 is 45, and then half of 180 is 90. And sine is positive in between 45 and 90. So this guy is out. So it's between B and E. So let's see which one it is. I'm going to put it in blue, guys. So sine of half A is equal to plus minus, we already know it's a positive one, square root 1/2, 1 minus cosine A. So I need cosine A. So I know that A is 3/5. So I'm going to do it here in the little side here in the little corner. Here's angle A. And that was sine, so this is 3, that's 5, so this is -4. So, square root 1/2, 1 minus a -4/5. That's what cosine is, guys. Cosine is -4/5. Minus a negative, that's going to turn to a positive. 1/2, 1 plus 4/5. So, I'm going to turn that 1 into 5 over 5. 5 over 5. 5 plus 4 is 9. 1/2. 5 plus 4, so I have 9/5. 2, nope, 2 doesn't go into anything. So I have the square root of 9/10. And remember, we already chose positive, right? The square root of 9 is 3. So 3 over the square root of 10. And there it is. Yay. I hope you guys like that, guys, because that was actually kind of cool. All right, this one is coming from your exam. It wants you to use your angle sum or difference properties. That's just your composite argument properties. It's cosine, and I wanted to add up to a 7. So I'm going to write up here cosine, and I can think of two numbers that when you add give you 7. I'm thinking of 3 and 4, and immediately I see that 3 goes into 12 and 4 goes into 12. So I can write this as 3 pi over 12 plus 4 pi over 12. Notice that it's still 7 pi over 12, guys. That's cosine 7 pi over 12. Now, the 3 goes into 12 4 times. So I'm going to rewrite this. Here we go. I'm going to say cosine pi over 4 plus, and then 4 goes into 12 3 times. Pi over 3. I'm hoping that that's making sense to you guys. So now, I'm just going to go ahead and plug it in. Hold on, I got to sneeze. Maybe I can edit that out. Okay. So here we go. Cosine pi over 4, cosine pi over 3, minus, because it's I almost put a plus there, but it's minus because the cosine toggles the sign, toggles the symbols here, that sign there. Sine pi over 4 sine pi over 3. And now the unit circle comes back. It never goes away, guys. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is half, minus sine pi over 4 is square root of 2 over 2. And sine pi over 3 is square root of 3 over 2. So let's see what that is. Square root of 2 over 4 minus square root of 6 over 4. So square root of 2 minus square root of 6 all over 4. All right. This one's a neato question. It's kind of fun, I think. So the way to do this one, guys, this is very similar to your algebra days when you had 2x squared minus 7x minus 4 equals 0. It's similar to that. So when you factor this out, two numbers that when you multiply give you a 2x squared, that's 2x and x. And then two numbers that multiply give you a negative 4, but remember you have to add up to negative 7. So you could try 2 and 2, but that's not going to add up to negative 7. So it has to be 4 and 1. The 4 is here because 2 times 4 is 8. And the 1 is there because 1 times x is just 1. And the difference between 8 and 1 is 7. Now I want it to be a negative 7. So that means that 2 times 4 has to be the negative. So that's a negative there. Oh, it came out kind of dumb there. Minus. And this one has to be a plus. So since this is similar, that means that I have 2 sine x plus 1 sine x minus 4. And that equals 0. Since it equals 0, that means that sine x equals 4, but that's never going to happen. Sine x are values between negative 1 and 1, but this one does happen. So that means 2 sine x plus 1 equals 0, 2 sine x equals negative 1, sine x equals a negative half. On your unit circle, it is negative half in quadrant 3 and quadrant 4. If you remember that, this one is 7 pi over 6. And this one is your pi over 6 away from completing 2 pi. So that one has to be 11 pi over 6. So there it is, 7 pi over 6 and 11 pi over 6. All right. Last one for your response. Mr. Wentz. Yay, Mr. Winners. Mr. Winners. Mr. Wieners. Okay. That's enough of that. Sorry. If you're seeing this, Mr. Winners, what's up? I love you, man. Be happy. Okay. All right, Mr. Winners is riding his bike. He turns the pedals at 90 revolutions per minute. The dimensions of the bicycle are shown to the right, so there's the dimension of the bicycles. What is the angular velocity of the pedals in radians per second? Okay, so I want the angular velocity of the pedals in radians per second. I already know how fast you're spinning them. So 90 revs per minute. And in one revolution, you cover 2 pi radians. So there it is. I have radians per minute, but I want radians per second. So in 1 minute, you have 60 seconds, and then that's it. I do not know what that is. I need my little calculator. So I'm going to go 90 times 2 pi, enter, divided by, what's going on here? 90 times 2 pi, enter, divided by 60, and I guess I get 3 pi. Did I do all that correctly? 9 times 2 is 18, 180 pi over 60. Yeah, I guess I did that right. Yeah, so 3 pi, and I need units, radians per second. If you don't want 3 pi, you can leave it as a decimal as 9.42478 rads per second. All right, what is the linear velocity of the chain in centimeters per second? Well, you already have it in radians per second, guys. So just convert that, because that's how fast this chain is going, because that's when you pedal, it's connected to that front link there, or that front sprocket. So 3 pi radians per second, and since it's connected to the front sprocket, let's see, the radius is 10 on this guy. So in 1 radian, you cover 10 centimeters, because really 1 radian just means what's the radius. So there it is. That's going to give me centimeters per second. So it's going to be 30 pi centimeters per second times 10 So 30 pi, if you want a decimal, it's, well, I guess just move the decimal one time, right? 94.2478 centimeters per second. What is the angular velocity of the back wheel? Okay, so I want to know how fast this back wheel is spinning. So to do that, this chain is traveling at 94.2478 centimeters per second, and we're going to convert that to an angular velocity. So you can either do it with a scale factor, or we can do it with this guy. It doesn't matter to me. I'm going to take the 30 pi centimeters per second, and in the back sprocket, in 4 centimeters, you have 1 radian, because that's what the radius is. You could also do a scale factor of 10 to 4 and then do that, no big deal. Why am I doing the back sprocket and not the back wheel, guys? If the little guy spins one time, the big guy spins one time. And it doesn't care about how I have the angular velocity. It doesn't say, it just says what's the angular velocity. So I can leave it in radians per second. I can leave it in revolutions per second. I can leave it in whatever dimension I want, as long as it's an angular speed. All right, 30 divided by 4 is 15. So this is going to be 15. Oh, well, 30 over 4 is 15 over 2. Sorry, guys. It's not just 15. So 15 pi radians per 2 seconds. So I guess 15 pi over 2 radians per second. That's the angular velocity of the back wheel. You still would have gotten that, guys. So look, let's say, or you know what? Let's go ahead and, what else do I want? I want it in revolutions. Let me do that. Look, I just want to show you guys something real quick. 15 pi radians per 2 seconds. And in 2 pi radians, there's 1 rev. And I guess let's go ahead and make it even funner. In 60 seconds, there is 1 minute. So look, check it out. 15 pi times 60, and I'm going to divide that by 4 pi. And I get 225. Oops. I didn't mean to cancel the minutes there. I meant to cancel the seconds. 225 revolutions per minute. What I wanted to show you guys is this. You see this 90 revolutions per minute? The scale factor between 8 and 20. So let's see what that is. 20 over 8. 20 divided by 8, and I get 2.5. So that means that this little sprocket, the little back sprocket, is going 2.5 times faster than this big sprocket. So what that means in layman's term is every time this front sprocket does 1 revolution, the little sprocket does 2.5 revolutions. Now remember, the back sprocket is tied to the back wheel here. So having said that, oh look, I didn't even know I had that. I just learned that right now. Having said that, I lost my train of thought. Oh yeah. Having said that, if the front sprocket is going 90 revolutions per minute, if I multiply that by 2.5, that should give me the angular velocity of the back wheel. So check it out. If I go 90 times 2.5, you do get 225. 90 times 2.5, you get 225, which is again angular velocity. Cool, right? All right, here we go. Finally. I'm going to use this guy. Well, you know what? It doesn't even matter. Yeah, no, it does. How fast is wind going in kilometers per hour? I'm going to go 15 pi. Oh, no, we can't. Yeah, we can. This is the angular velocity. Radians per 2 seconds here. And I'm going to say in 1 radian, I cover, let's see, look, that's 70 centimeters. So that's 35 centimeters. Hold on, I gotta pause this really quick, guys. All right, I just resumed it, guys. Sorry about that. I had to answer that phone call. Let's see. In 1 radian, there is 35 centimeters. So I put 35 centimeters right here. So now I have centimeters per second. And now I want to convert that to hours or kilometers per hour. So in 100,000 centimeters, there is 1 kilometer. That's from your kilo, hecto, deca, base, deci, centi, milli. And so please make sure you know that, guys. So 100,000 centimeters in 1 kilometer. 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. And let's see, in 3,600 seconds, there is 1 hour. I think I did that right. 60 times 60, 3,600. Yeah. All right, so let's go ahead and take care of this. 15 pi. I'm going to go ahead and 15 pi times 35 times 3,600. And I get a big number. I'm going to divide that by, and I open parenthesis, 2 times 1, 1, 2, 3, 4, 5. And let's see what I get now. I get 29.6881 kilometers per hour. If I didn't make any mistakes, I believe that's my answer. And we are done, guys. Yay. All right. I hope you guys like that, guys. Thumbs up, please. And that's it. Later. Bye.